Hello everyone, I'm Chad, and I am working on a tutorial for your guys' Project 2. And what I'm going to do is I'm going to, today, teach you how to bring an image into Rhino. And then we'll go over how to trace it and some strategies for tracing it. And then we'll talk about using that tracing to create a series of elevations which describe a three-dimensional object. And we'll be sticking to the line drawing commands that you went over in the last project and that Erica covered in her tutorial. So if you need any refreshers on those, I'll be mentioning them in passing. But if you need a serious refresher, go back to those earlier tutorials. And yeah, so that's just where we're headed. And then I guess let's just get into it. So to start, and I presume if you're following along, you'll have these images. If you don't have these images, you'll get them in the future. But to start, what we're going to do is we're going to bring an image into Rhino, a rasterized JPEG. And so we'll type in the command picture, and this window for your file directory will come up, and then you'll be able to select any image that's a JPEG, a PNG, or any of these other files, which I don't really know what they are. But this is our image for now, and we'll bring it in, and it first asks you to select a base point and then another corner length, like up here. And we can just sort of arbitrarily toss this thing in. And then, I'm just going to make sure that this thing's square. And if it's not, we'll like trim away a little bit of it. So what we're going to do is we'll just type in the trim command, because it's sort of rectangular. So we just want to make sure it's a perfect square, because we're going to scale this down to an 8x8 image. So to do that, we're going to select the image that we brought in, and we'll type in scale, and now it'll ask for a base point. So it asks for a base point, and you will select the corner up here, or whichever corner you choose. It doesn't really matter. And then you'll select another point on this. And because our known dimension is 8x8, we'll select the width here, the opposite corner. And now it'll allow us to scale this image within the XY space. And we can either arbitrarily scale it by clicking again, and it will resize that image, or we can type in a specific number. And so I'm going to type in 8 inches, and it will scale this image down to 8 inches, because we're working sort of on an 8-inch, in an 8-inch system. And now, what we're going to do, let me move this line here. Now what we're going to do is we're going to go ahead and trace this image. And we'll trace it to try and extract logics within it. And I'm going to pick some pretty arbitrarily simple ones, because I'm not necessarily designing this thing. I'm just trying to give you guys the steps you need to, or the skills you need to do this project well. But I'm going to do the project poorly. So when you guys are tracing, you'll want to look very sort of in-depth at this thing, study it a million ways, maybe print it out and draw over top of it, trace it that way, use your trace paper, use big markers, use little markers, use everything in between, to try and extract the sort of logics within it and come up with some idea for the way to trace it. I'm just going to go over a couple of those things, and then we'll trace it in Rhino, which is we'll use in the future. We're sort of making a plan out of this thing. So what we're going to do first is we're going to make sure that this image is on its own layer, and we're going to switch to this trace layer, and then we'll lock this image. And you'll notice now that doesn't matter how hard we try, we just can't select it, and that's made this thing locked within the space. So we can move things around and we can draw, over top of it, like so, but we'll never be able to affect the image. And that's great, because now we can turn it on and off, and we're not sort of like, we won't be modifying our background, which is important for tracing. And so what we're going to do, now that we are on our trace layer and our base image is locked, we're going to just, draw over top of this thing and find some different logics within it. So something I'm noticing here is, Erica and I did this earlier. We traced over this a million times and sort of had a fun time of it. And the whole time that I was tracing it, I was following lines, extending lines off of these. But Erica, very quickly noticed the spiral logic in this, which I never even noticed, when I was first working on it. So there's lots of different things in these images that you can pick out. So just know that it's sort of a rich terrain. And what I'm going to do is I'm just going to copy this line down any place it intersects with one of these lines within the painting. And maybe that will yield results, maybe not. And how I'm doing that is with my gumball on. And if you don't see this little thing with the red and green arrows, it's called the gumball. You can just type in gumball, like so, and then it'll give you on and off toggle options. And you can, right now it says gumball is on, so whenever I click an object, select an object, the gumball will show up. And what I'm doing is I'm grabbing this green arrow, dragging it, and then I press Alt or Option if you have a Mac, and I release, and it makes a copy of that object in the new place that I've dragged it. So I'll keep doing this down, you know how it is. And you'll just have to bear with me here. And try not to miss anything. And then copy it down some more, like so. And then we'll repeat this in the other direction. Luckily for you, you get to just enjoy as I trace this. But maybe this will yield results for us. And again, now I'm just dragging the red arrow, the X axis in the gumball, and then pressing Alt to make a copy. However million number of times I need to do this. And this is just one lens of viewing the image, one way of tracing it. And it's also not inherently this act of tracing a rasterized image with vector lines is a super inaccurate process, because at some point I can try to match this as well as I can, but at some point I zoom in infinitely and this is all just fuzzy and gray edges because it's a raster image, and my lines that I'm drawing are super crisp still. So it doesn't have to be perfect, release the inner perfectionist within yourself, and the purpose of this is analysis, not perfect, not perfect reconstruction. It's, diagrammatic analysis. And now when we, toggle this image on and off, maybe you see something there. There's differential density around this thing, sort of in a spiral. You can maybe pick that spiral out, maybe not. All in all, this lens isn't necessarily super helpful, but that's fine. I'm just going to move to another lens and hide that one, and I'll call this one Trace 2. And now I can toggle these on. I'm going to switch this color as well, pink. And now I'll get this image back, unlock it real quick, and give myself an exterior bounding rectangle, and unlock it again. And for this go around, I'm going to pick out the sort of obvious diagram in this thing is the relationship between the black rectangles, the gray rectangles, and the sort of white light gray space. I might call that a solid void relationship, and this is the lens I'm going to use in order to begin constructing elevations off of this image. And if your snaps get a little too tight, you can zoom in. And again, you know, there's like, I'm missing edges, but it's okay because it's a trace. It does not have to be perfect. And it's a spiral, so like, you know, it just isn't perfect. It's a painting. There are all sorts of, you know, off orthogonal edges and whatnot. But I'm gonna sort of cull all those inconsistencies for the sake of ease. Yeah, and now when I turn this off, I have this diagram of the thing. And now I almost want to shift the attention, and I'm going to cease to call this a painting or you know, I don't know what I've been calling it. But now I'm going to start referring to it as a plan, because that's how we want to think about this. Maybe we're looking at a thing top down, some kind of three-dimensional geometry. And our job is to tease out what this geometry is and how it presents itself. Like what does this thing look like in elevation? If we were a person standing here looking at it from this direction, what are we seeing? Or yeah, so and that's sort of the lens I think that we'll use to move forward. So what I'm going to do now, we have our 8x8 inch rectangle, and we're going to want to have an elevation for each one of these sides projected off into space. So we'll copy and paste this bounding rectangle, Control C and then Control V, and then we'll move it up 8 inches. And that just moves it so it shares an edge with the plan. And then I like a little bit of space between, just to give my elevation like some difference from my plan. And so I'm going to move it 2 inches above. And it's important that all of your elevations are the same distance away from the plan. And I just mirrored it across the central axis. And now what I'm going to do is I'm going to use the gumball to rotate and then press Alt to copy. Now we have our set of 4 elevations that are necessary. And at this point, we begin sort of conceptualizing what this 3D object looks like. And I've already done this a time or two with this specific plan. And so I'm going to sort of zoom over and show you guys where we're going with this thing. Because I'm going to reconstruct what I've already sort of thought up in my mind for the sake of, you know, streamlining the tutorial. And so here we are, over in the, don't mind don't look at my layers. They're grody, you know, and you should have better layer management than that. But so this is sort of where we're headed with all these different elevations and roof plan. And this, for example, this is the outline. This is the front face. And between all of these, each elevation and the plan looking up at it from the top and looking up at it from the bottom, we have constructed this kind of three-dimensional object in space. And we're going to attempt to just I'll show you how to, you know, reconstruct this, or at least a couple elevations of it, just the basic principles. But I want to stress, and I can't stress this enough, this is by no means an exemplary example. It is not something to like model your aspirations to. This is my a really quick attempt to just make something for the sake of teaching you guys the principles. Whereas the design isn't something to like covet or aspire to. There are things within this. For example, my strict division between top half and bottom half, between plinth and top, that aren't necessarily, they're not things to necessarily avoid, but they're not things to aspire towards. So I want to make sure that you guys know there's an infinite number of possibilities of ways to interpret even this singular plan. And this is by no means the single way of doing that. So anyway, and you'll see now also this like confusing, messy web of construction lines which it took to generate these elevations from this plan such that they all coordinate one with another. And I'll begin showing you that, and we'll continue to continually refer back to this thing that we're moving towards, just for the sake of clarity. Anyway, all right, moving back to this. Let's start, I think, the best way is by drawing the elevation which occurs on this line here, which I've selected. And that elevation is going to be up here. So to start that, let's move to our construction lines layer, and then we'll draw a line. Also, I can't stress enough, you guys should all begin thinking about making shortcuts within Rhino, and maybe this is a tangent, but if you go into properties and then I probably shouldn't have gotten into this, but I'm here, so I think it's in aliases. You'll notice there are all these different, they're called aliases for different commands which are shortcuts. So for example, ZS, zoom selected, is one of these, where if you just type in ZS and enter, it will automatically do that command, so that way you're not having to all the time type out zoom selected. Or I have M for move, which I think you guys have as well. And I have all these different things. They're just modeling aids to help me model faster. And then there are also ways of making shortcuts. So I have in my shortcuts, if I just do Control A, it queues up line command for me immediately. It's something which greatly speeds up modeling time or drawing time. So if you ever see me like queuing up commands really quick, that's how I'm doing it. And it's not difficult, and it'll save you tons of time. Anyway, so what I've done is I've taken from these things, these little rectangles, which I'm taking to be extrusions above the plinth, referring back to my drawing here. And here's like a little step process of that. What I'm taking to be extrusions above the plinth, let me turn off those construction lines. I'm taking these rectangles, represented here, to be extrusions above this big base. So I'm taking these and moving them, projecting lines from the edges of those rectangles up into the elevation. And now I'm thinking of it as this plinth, this thing is divided into two halves, a top and a bottom. The bottom is sort of a massive solid thing, and the top is a much lighter, like projected crown or something. And because I have this strong axis within this, I'm just going to draw that center line here. And now you can almost already see it taking shape. Let me get back here, and I'm going to move to my keep lines layer, which I'm actually going to move. You can move layers up and down using these little move up keys in the layer tab. So I'm going to move those above my trace. And what that allows to happen is when I draw a polyline, for example, and bear with me as I draw this line. When I draw a polyline, that black layer displays above my construction lines and my trace lines. So it allows me to more easily visualize what the elevation is shaping up to be. Whereas if this layer, for example, was hidden behind, I wouldn't necessarily know what I've actually drawn, what my elevation is. And even more so, if my construction lines were there, I wouldn't even see the black. I think it's important too to keep your contrast heavy between each of these different layers, because if, for example, trace was black, I wouldn't be able to differentiate between what are my dark lines, or what are my finished elevation lines, and my just process drawing lines. Anyways, so now I've sort of drawn, you can see the partee of this, but I'm not necessarily content with how divided up this is. So I'm going to vary these in heights. So I'm going to shorten these three by half about. So I'm going to do is I'll draw another construction line here, and by pressing B I allow that line to extend off in both sides, and then by holding shift I constrain it to the orthogonal directions, which would be 90 degrees. And now what I'm going to do is I'm going to, using this new line, I'm just going to retrace that polyline, making sure to select my active layer as keep lines. And now I'll do that. This little one at the end, I'm going to take all the way up just because it's sort of funny. It's a funny little tall guy there. And then I'm treating these rectangles as at some moments solid, but at other moments void. So as they interact with the plinth, they might become voids or openings within the solid mass. And so looking back over here, you see how that might happen. There are these little like cutouts in the elevation. So now going back here, I want those cutouts to occur, let's just say midway across. Let me switch my active layer to construction lines, midway up, and now switching my layer back to keep lines, queuing a polyline, I will draw these little cutouts. I hope this is all making sense, and if it isn't making sense, and you guys find yourself hopelessly stuck, thankfully there's a great crew of ISAs who are more than willing and capable of helping you, and they have office hours listed. You're welcome to go to them. You can also email any of us at any time. Well, keep it reasonable if you have questions, and we'll get back to you as soon as we're able, although we are busy, so I'll confess that. Anyways, so now we have this front elevation, or at least just the broad strokes of it. It's only the surface which occurs at this line here. And we want now to get this elevation, which is the elevation which occurs here. But you'll notice that there's some overlap here. So I know this gets a little bit abstract, but this corner here is shared by both, or this rectangular extrusion is shared by both this elevation and this elevation. So we'll need to use lines to project across to make sure that we're keeping things consistent. So the way to do that is we're going to use 45-degree lines to project across our drawing, 45-degree construction lines to project across the drawing to take information which occurs here and bring it onto this elevation. So how we'll do that is we'll switch to the construction lines layer and we'll draw a line in space. We'll select that, and then clicking the arc, this blue arc here in your gumball, if you click it once, you'll notice this dotted circle with these arrows and a white bar that you can type into. These arrows indicate what would be the positive direction, so it's counterclockwise is positive. So if we want to rotate things in the clockwise direction, so that's negative, so we'll type in minus 45 or negative 45, and it will rotate it just like that. I guess you could rotate it like positive 270 or something, and that would give it to you. I don't think 270, but anyway, that'd give it to you too, just like positive all the way around. But the negative works a bit more easily. And then we'll take this line and we'll move it to the point at which this spire interacts with this edge, because this is where the elevation occurs, right here. And then we'll extend this construction line to there. And then we'll copy it to any place where there's a significant interaction between this edge and and this spire, or in this elevation. And then we'll take from these intersections between the 45-degree construction line and the exterior edge, this edge, which would be the shared corner of this elevation, will project up construction lines, just like so. And now that gives us our the quartering off that that I've designed into this three-dimensional object that we're describing. And now we have, if we take construction lines over, we have exactly where this corner spire occurs. And then again, repeating the process, taking construction lines over, we can sort of begin to interpolate or design what this elevation ends up being. And it's important that we're coordinating between this corner, but over here we have yet to design this elevation, this side of it. There's no information that we're carrying over between. So we have freedom to make the decisions we want to make without it having implications at this point on the rest of the drawings. But in the future, the decisions we make will have implications for other aspects of the drawing. For example, this area will occur in the background here. And so you'll want to make sure that you're coordinating so that all of your elevations are describing a single three-dimensional object. And this is just, it's a pretty fun process. It's like solving a puzzle, or, and you get to make lots of design decisions and sort of impromptu judgments about what you think looks best or what you think looks worse. And that, it can be a sort of fun, but it's also a delightful challenge, or at least I found it to be. Anyway, moving forward with this elevation, because we get to make the decisions we want to make here, I'm going to cue into polyline, switch my layer to keep lines, and then I'm going to take this one all the way up, knowing my plinth occurs halfway through, and then this one, I'm going to make it flush, or maybe it's a gap. So what I'm going to do is I'm going to make sure that that describes a gap. This one goes halfway up, as does this one. And this one is the only one that has to go halfway up because we've already made that decision up here, if that makes sense. And now we'll fill in the rest of those lines here. The other thing is there's a cutout here where this becomes a void at this bottom quarter of the plinth. And so we'll indicate that as well. And then let's make it solid at this corner and then void here as well. So now, when we turn off those construction lines, that's what we're left with, this elevation, which you'll notice I've made different decisions here than I did over here, but that's sort of okay because we're defining a new object. Yeah, the next thing that I think is important to do is we're going to define, we're going to use the elevation that we've used here, which, remember, is here, and this elevation to decide what happens in the background in this row, because we have both elevations figured out, if that makes sense. So what we'll do is we'll take construction lines, cue into our construction line layer, and pull these lines over. And it begins getting a little muddy here. But importantly, you'll notice that these little extrusions here, these nubs, will not show in elevation behind this nub here in this elevation. So these sort of go away. So let's just go ahead and delete those construction lines because these nubs are hidden behind this nub. But because this nub here, the skinny nub, extends all the way to the top of our elevation, or the top of our bounding box, we will see it behind in elevation. So if we know it extends all the way to the top, and is this thick, then we can define moving to our keep lines, we can define it as such. And now turning off our construction lines, that's what that looks like behind. The next step, assuming that we're done with all of this, like we've completely described all these drawings, we're finished up. The final step here is using then the three-dimensional object to set line weights. For example, if we know that this nub here, this skinny one, extends all the way to the top, in our topmost view, or plan, this will be the darkest line because it's the closest to the viewing plane of the orthographic drawing. So this will be the darkest, whereas the plinth, which is here, is the lowest thing on when we're looking down, at least for now, it is. So this plinth will be the lightest line weight, and these will be at some midpoint between that, because they extend midway between this topmost level and this bottommost level as it presents itself. One more time, I'm going to remind you guys that this is just sort of a generic designed object that is by no means exemplary and is not necessarily to be emulated in any way. You guys should be making more intentional decisions than I'm making, and really tease out the logics of your input drawing, or this base image, tease out those logics and allow them to sort of percolate into what your three-dimensional object ends up being described as. So yeah, I'll sort of leave you guys with, maybe I'll turn on these construction lines one last time so we can look at them and the way that all of these different 45-degree angles correlate with different points on other drawings. And yeah, I hope that you guys are able to follow this tutorial somewhat, or at least it prepared you enough to be able to tackle the challenge of Project 2, at least at this moment. So that is all for now. I hope you guys have a great rest of your day. Adios.